This tutorial will explain exponential growth and decay equations. So you notice that the equations are quite similar. The only difference is one is an addition and the other one is a subtraction. An exponential growth is when you have more than 100% of what you started with. An exponential decay is when you have less than 100% of what you started with. And because what you start with, known as the initial amount, or the A value in this situation, because you have 100% of it, that's where this number 1 comes in. So we're either going to add more percentage rate, or we're going to subtract some percentage rate. The 3 variables that require information from you are A, the initial amount, R, the percentage rate of change, and you have to express it as a decimal. So if I say we are going to increase 8%, you have to write that as 0.08 or 800ths, right? 8 per 100, 800ths. If I say we have a 25% increase, then you would write 0.25, 25 hundredths. And if I say that we're going to have a 1.5% increase, then you would write 0.015. So this part can be a little tricky. Sometimes students forget to move the decimal point, and that's what creates errors. The last variable that needs to be replaced is the letter T, and that always stands for the length of time for which the growth or decay will be occurring. So let me show you an example already completed. Up at the top here, we have our 2 choices, growth or decay. Here's the question. And this right here on the left side, this is just a scaffold for you, an attempt to help remind you of what each variable represents. But you don't have to write that down. So if we were to read this question, the original value of an investment is $1,400 or $1,400. So that would be our initial amount. That would be our replacement for the A variable. The value increases by 9%. This is where I start to choose my function. So because it said increase, I'm going to choose the growth function. And because it says increase by 9%, I'm going to convert that value to a decimal number. Then I keep reading, saying that the exponential growth function to find the value of the investment after 25 years. So T is 25. This is something that needs to be identified by you, but this is where you start your work. You write the equation with the correct values substituted into each variable position. From here, you use your calculator. Now you notice you can either write the plus sign or you can complete that plus sign before you type it in your calculator. Either one, it doesn't matter which choice you use. Oftentimes using this choice prevents any minor mathematical errors. You'll notice my final answer is quite a long number. The decimal goes many place values, but since we're talking about money here, we will round to the nearest hundredths place or the pennies. So in 25 years, our $1,400 investment will now be worth $12,072.31. All right, let's take a look at a new question. The value of a car is $18,000 and it depreciates. So that means this time we're going to use the decay formula. It depreciates at 12%. Notice that I converted that percent number to a decimal number and that it's going to depreciate for 10 years. Write all of those values into your equation and compute. Again, I get a really long decimal answer. I round to the hundredths place because that's pennies, and this time it would round up to $5,013.18. All right, let's try one that hasn't been completed. Miss Acosta received a job as a teacher with a starting salary of $34,000. According to her contract, she'll receive 1.5% increase in her salary every year. how much will Miss Acosta earn in 7 years? So if we identify our values here, we're going to get an initial amount of $34,000. We're going to get a percentage rate of 0.015 and a length of time of 7 years. So now you're going to need to get your calculator ready. You don't have to write each of those 3 values down the way that I did here. I'm just making sure that you know where I'm getting the values from. The only thing you would need to write on your paper is the actual equation with the amounts filled into these variable positions. So this is really the only thing you would need to write. That your function has an initial value of 34,000. That it has a growth rate or an increase of 0.015 and a length of time of 7 years. So let's get our calculator out and compute. So 34,000 parentheses 1 plus 0.015 parentheses raised up to the 7th power. And again, if you get a long decimal, you'll round, since we're talking about money, to the hundredths place. So that's $37,734.73. All right, let's take a look at another one. In 2000, 2,200 students attended Polaris High School. The enrollment has been declining 2% annually. So this is a 2-part question. The first one asks you to write the formula. The second part then asks you to evaluate it. So let's identify our variable terms. 2,200 initial students. 0.02 is our rate. And from 2000 to 2015 would be 15 years. The initial question says to include the value t. So our function would be 2,200, 1 minus 0.02 raised to the t power. That's the first question. The second question says, now you can evaluate your formula. Whoops, forgot a 0. Now you can evaluate your formula for the amount of years. Now you don't have to perform this mathematical operation here. I'm just doing it to show you that you can simplify, but also so that you can see that the rate of change here is less than 1. So that's another visual image that this is decay, right? Anytime that growth number is less than 1, we know that it's decay. So you pick up your calculator and you type in these values, 2,200 parentheses 0.98 raised up to 15, because 15 years later. So there would be 1624.85. Now we're talking about people, so there would be approximately 1624.9. We could say 1624 because we don't actually have another full person, or we could round it up to 1625. But since it didn't make it to the next full person, I'm going to say 1,624 students. All right, let's take a look at some other possible questions you could see on the Regents exam about exponential growth and decay. Take a minute to pause the video and choose a selection. Okay, did you pause the video? Have you got your answer? So some of the important pieces of information are identifying the initial cost or value, but all of these match, so that doesn't help. The value after 3 years, so these all match, but that one is different, so that one is not exponential. So we've narrowed it down to the first 3 choices. So of these first 3 choices, which one shows that we are losing value? Right? We are losing value, so that's this quantity, right? We should be less than 1. So this one can't be right because it's higher than 1. So it's got to be either the first or second. But remember, you started with 100% of the value, and then you lost 0.14. So it's not just 0.14. It's the whole amount of the value, then minus 0.14. So the correct answer here was number 2. Let's try one more. The cost of tuition at a college is $12,000 and is increasing at a rate of 6% each year. Use an exponential function to find the tuition cost after 4 years. Go ahead and pause the video and try writing your growth equation now. All right, you had your initial value of 12,000. You have 100% of the cost plus an additional 0.06, and it will grow for 4 years. So we have 12,000, parentheses 1.06, raised up for 4 years. And so $15,149.73. Let's try another one. Pause the video and see if you can fill in these values. All right, let's take a look. I have an initial value of $50,000 for the tractor. It depreciates 0.10, and we're going to track it for 7 years to see what the new value is. So 50,000, and we lose 10%, that's 0.90. And for 7 years. After 7 years, it will be worth $23,914.85. One more time. Pause the video and write your exponential equation. All right, let's take a look. Now you can use y equals or f of x. It doesn't matter since it doesn't specify. And we had a starting amount of 28,000. And it's decreasing at 0.025. Be very careful with your placement of the decimal. That's the most common mistake. So the expected population will be 28,000. 1 minus 0.025 raised up to the 15th power. 19,152.57. So we don't have enough to get to the next person, so I'm going to leave it here. Hopefully you're getting the hang of it. Let's take a look at a couple more Regions questions. Pause the video and take a minute to read this. All right, let's take a look at some of our values here. All of the initial values are matching. All of the exponents are matching. So this is your focus. First, you need to identify whether it's growth or whether it's decay. And that will help you to eliminate 2 of your choices. She made no deposits or withdrawals from the account. Interest is compounded annually. Which equation represents the balance? So she is earning interest. So that's growth. She's earning interest at a rate of 1.3%. 1.3% is 0.013 added to 100% of the initial value. So this would be our answer. All right, let's take a look at another one. Pause the video, take a minute to come up with your answer. Okay. A high school sponsored badminton tournament. It's hosting 64 players. That makes sense. It says how many will be left after 3 rounds. So that's the length of time. So these do not make sense. So these are out. If after each round 1/2 of the players were eliminated, then that means you have decay. And 1/2 is 50%, or 0.5. Now remember, that's decay. So we're going to go with number 1. Alright, one last question. Take a moment to pause the video and find your response. Alright, let's think of some basic knowledge information here. All of the values have the same initial amount. All of the exponents have the same value of 5. So we can't use any of these values to help us to eliminate any choices. But we do know that he's losing value. So what do we know about these quantities if we are losing value? We know that that quantity needs to be less than 1. So these can't be right. Now the question is, which one of those values is correct? So I had 100% and I'm losing 0.045. So that's the quantity you're looking to see the answer for. So 1 minus 0.045 is what you're going to be looking up. So hopefully you know that is 2. All right. If you were given this exit ticket in class, give it a try. If you're looking for the solution, remember any number in the quantity here that is higher than 1 is growth. It's growth. And remember that it became 1.02 because we added 1 plus 0.02, which converted to a percent, is 2%, not 0.02%. So this is 2% growth. Good luck.